if we distribute the 5x, then we'd get 5x squared minus 15x, which still wouldn't help us simplify in this case. So let me see. Let me try it. I'm gonna try and see on the side if that'll happen. So what I'm gonna do is I'm gonna distribute the 5x with each of these. So we'll get 5x, so this one times this one, and then times this one. So we're gonna get 5x squared minus 15x, and then we'll have plus x plus 3. So as the numerator, we have this right here. I just went ahead and distributed the 5x. And now if I simplify this, it'll become 5x squared minus 14x plus 3 over x minus 3 times x plus 3. And if I factor this, I can't factor out 5 from each of these. So for this one, it looks like we kind of hit a stopping point here. So if we notice, if we go back to this part right here, this is pretty much where we stop, because we can't simplify this anymore. We can't cancel out the x plus 3 or x minus 3. So this would be your final answer. The only thing you need to mention is the excluded values. So the excluded values for this one would be any values that you can plug into x that would make each of these factors a 0, because we can't have a 0 in the denominator. So for this one it would be 3, for this one it would be negative 3. So then our excluded values, we usually write it as x can't equal 3 and, or let's put or, negative 3. So those are your excluded values, and this is your answer. So here's your answer, and then these are your excluded values. Those two are part of the same part of the answer. All right, let's move on to B. So for letter B, we have this big 1 right here. Think of this 1 as a big 1. So just like we were able to think of this as a big 1, we can think of this big 1 as becoming anything we want. So in this case, we want it to become something that's going to help us. So if we look at this fraction, it has a denominator of x minus 1. So we want this big 1 to become a fraction with a denominator of x minus 1. But in order for this to be a big 1, it has to be the same on both top and bottom. So we're going to have x minus 1 over x minus 1. And notice that since it's the same thing over the same thing, it could be this, it could represent this big 1, right? And now I can say, okay, well, I can rewrite the rest of my expression the same way. So now I have x over x minus 1 minus this right here, which, if you think about it, could become this big 1, right? But this is going to help us now because we have the same denominator, and now we can combine this fraction. So now we can say x minus 1 over x minus 1. Okay, and now this is equal to x minus x is just 0, so we're just going to be left with minus 1, and on the bottom x minus 1. So our final answer is negative 1 over x minus 1, or negative 1 over x minus 1. So this is our final answer. And the excluded values, we write it as x cannot equal. We just have to think about what x value would give us 0 here, so it would be 1. So in this case, x cannot equal 1. So that's our final answer right here. For letter C, we need to factor the top, we need to factor the bottom. That way we can start seeing what we need here. So this polynomial right here, we can use a diamond problem. So we have 6 and 5. So 3 and 2 are our factors. So the top is going to be written as x plus 2 times x plus 3. The bottom, when you have an x squared term and an x term, it's easier to factor. We just need to factor out the x and any numbers that are the same or common to both of them. This one we don't have a coefficient, so all we can factor out is an x. So we can rewrite it as x times x minus 4. And this one we have times 4x, x plus 2. So now that we see, we're going to end up multiplying across, so our numerators and our denominators. So we're going to get x plus 2 times x plus 3 times 4 times x. This 4 and this x, you can think of it as 4 times x, right? So we have times 4 times x. I just expanded 4x a little bit so you can see that it's going to cancel with some of the bottom parts. On the bottom we have x times x minus 4 times x plus 2. So that's what happens when you multiply fractions. The bottom stays on the bottom, multiplies all together, and the top stays on the top, multiplies all together. So now we see that we can build a big 1 here and here, the x plus 2 and the x plus 2, and that's it. So all we're going to be left over with is 4 times x plus 3 over x minus 4. So that's our final expression right here. And the last thing you need to do is mention your excluded values. So before you mention your excluded values, you need to look at your expression before you started canceling things out or building your big ones. So our excluded values would be found right here. So notice that we have x, x minus 4, x plus 2. So our excluded values are going to be 0, 4, and negative 2. Those are the values that if I plug them into the x, it would give me 0. So x cannot equal 0, 4, negative 2. Okay, so that's your final answer right here. And the last one. This one, notice it's talking about division. So we're going to have to flip the second fraction and multiply. So before I do that, I'm going to just start factoring everything out. So for this problem, I have the top one, I can factor it out to x times x minus 2. The bottom, I can factor it to, let me use the diamond problem. So we have 4 and negative 4. So I can see that negative 2 and negative 2 are going to be my numbers here. So this is going to factor to x minus 2 times x minus 2. And now I'm going to turn this into multiplication and flip the second fraction. So I have x minus 2, and on the bottom I have 4, let's say times x times x. So notice that I just expanded 4x squared to 4 times x times x. So now I can see that once I multiply these two fractions, everything's going to stay on the bottom, multiplied out together. So I'm just going to turn it into one fraction and say, okay, I'm going to end up with this. So everything's being multiplied together. And here I can see that I can cancel out or build a big 1. So I have a big 1 right here, big 1 right there, and a big 1 with that. Okay, so on top, think of it as 1 times 1 times 1, so you're just going to be left over with 1 on the numerator. On the bottom, we only have 4 and x left over. So there's our final expression, and our excluded values